Welcome to Math with Mrs. Bibb. Today we will be going over some problems that you will encounter on the summer work assignment number 3. Please be sure to roughly draw the sketch that you see here and then follow the instructions. First, we will decide if each of the following are linear or not linear. A linear graph is a graph of something that makes a straight line, no curves or no corners or turns in the graph. Number 1 and number 2 are straight lines. Number 3 and number 4 are not. So number 1 and number 2 are linear. Oh, oops. Number 3 and number 4 are not linear. Okay, and now we'll do the domain and the range for all of these. It doesn't ask us to tell whether or not they're functions, but if you look at all 4 of these, I hope you can tell that all 4 of them are not functions because every one of them would fail the vertical line test. Now let's look at domain. I'll grab a highlighter. Domain I'll highlight in red, and range I'll highlight in blue. Okay, so let's start with domain. For this first graph, how far left or right does this graph go? Well, it only goes to here. If you were looking at left or right, then it only goes to that point. Let me grab a marker to this point. So my domain is -3. That's it, -3. My range, which is how far up or down it goes, oops, how far up or down it goes, and that graph has arrows on the top and the bottom, so the range is all real numbers. Let's go back to red. The domain, how far left or right does this graph go? Well, just like number 1, it only goes to the left to -4, and that's it. So my domain is -4. And then how far up or down does it go? And just like number 1, its graph goes on forever, so all real numbers is the range. Okay, let me go back to my red highlighter. How far left or right does it go? Well, the farthest left this graph goes is 0 for x, and it goes on forever. I do notice something though. I hope you notice this. This is a little complicated. It goes from 0 to 3, and then from 3 forever. So this domain is just a little bit different. It goes from 0 to 3, and then from 3 forever. So the domain is 2 parts. It's from 0 to 3, and then greater than 3. So by writing it that way, it excludes the number 3. And then my range, how far up or down does it go? Let's look at that. The farthest up it goes is 5, and it goes down to -4. So open at 5, down to -4, closed. So my range is from -4 less than or equal to y less than 5. That's the range there. And then the domain for the next one, the farthest to the right this graph goes, looks like +2. And it looks like it goes forever to the left. So, whoops, undo that. It goes from +2 forever to the left. Solid forever to the left. So that would be x is less than or equal to 2. And then how far up or down does that graph go? Looks like forever up and forever down, because those arrows are going up and down forever. So that would be all real numbers. Okay, moving right along. So for 5 through 8, we have to look at these equations and decide if they are linear or not linear. So let's talk for just a moment about what makes an equation linear. To be linear, you have to have all positive whole number exponents equal to 1. So if you have any exponent that's greater than 1, it's not linear. If you have any exponent that's in the denominator, it's not linear. So let's go through these so we can talk about them. So number 5, I have n to the first power. This is linear because that is my largest exponent. Number 6, I have n to the second power and n to the first power. Well, that is not linear because of the second power. This is what makes it not linear. Now, number 7, and you may not know this yet, but this k is under a square root. The square root of k is equal to k to the 1/2. So that makes our exponent not equal to 1. It's not a whole number, it's not equal to 1. So this is nonlinear. And you should know this next one. You do learn that in 8th grade. You have b in the denominator, which means you have a negative exponent. So that means that number 8 is also nonlinear. So what makes it nonlinear? If you have an exponent on a variable other than 1, if you have the square root of a variable that is not 1, and if you have a variable in a denominator that is also not 1. So that's what nonlinear looks like. Moving right along. Solve each equation. Oops, see that n missing? I bet it's missing on the assignment too. Solve each equation or inequality. Graph the solutions to the inequalities. Okay, so this is an equation. We will distribute negative 120 equals positive 14m minus 28 plus 6. Combine like terms. So negative 120, 14m minus 22, add 22 to both sides. So I think that's negative 98 equals 14m. Divide by 14, so m will equal negative 7. The next one, distribute the negative 7. So negative 175 equals negative 21k minus 49. Add 49 to both sides. That's 15. This would be 6. 15 minus 9 is 6. 6 minus 4 is 2. And bring down the 1. So negative 126 equals negative 21k. 21 times 6. Is that 126? Yes, it is. So divide by negative 21. K will equal positive 6. That was like a 4. So k is 6. Remember, when you are doing these types of problems, you multiply numerator and denominator and numerator and denominator. So 5x times 7 equals 6 times x minus 6. So 35x equals 6x minus 36. Move your x to the left. 29x equals negative 36. Divide by 29. X will equal negative 36 divided by 29. That's the answer to that one. Multiply here, multiply these two, multiply these two. So 3 times n equals 9 times n plus 10. So 3n equals 9n plus 90. Subtract 9n. Negative 6n equals 90. Divide by negative 6. N will equal negative 15. 13, I'm going to subtract 8 first. So n divided by 2 equals negative 4. Let me speak just for a second about the fact why I did not cross multiply. It's because on the left-hand side, on this left-hand side, the 8 was not in the numerator, so I did not cross multiply. I wanted to move this 8 to the left. I could cross multiply next. If you want to make this over 1, then you could say you're going to multiply these two and then multiply these two. You can say that. That's perfectly fine. So n times 1 is n equals 2 times negative 4 is negative 8. You could do it that way. That's perfectly fine. The next one, I'm going to distribute the 4. I'm going to add 32. Can't remember what that is. Be 7. So negative 48, yes, equals 4v divided by 4. V will equal negative 12. Now I'm going to solve. I'm going to distribute. So 26 plus 2p is less than or equal to positive 16 plus 12p. I'm going to subtract 2p. So 26 is less than or equal to 16 plus 10p. I'm going to subtract 16. So 10 is less than or equal to 10p. I'm going to divide by 10. 1 is less than or equal to p, or p is greater than or equal to 1. And it's said to graph all inequalities. So greater than or equal to would look like that. The next one I'm going to distribute over here on the left. So 6x minus 24 equals negative 24 plus 8x. I am going to, oh, it's not equals, oopsie. Is less than negative 24 plus 8x. I'm going to subtract 6x. So negative 24 is less than negative 24 plus 2x. Add 24. 0 is less than 2x. Divide by 2. 0 is less than x, or x is greater than 0. So 0, open circle, greater than, shade to the right. For 17, it says evaluate each function. When you see the word evaluate, usually you're going to substitute. If you don't have to substitute, that's great. And then you're going to use order of operations. Now in this case, this is function notation. F of x is our function, and hopefully you can see here that x is negative 4. So we're going to substitute negative 4 in for x. And then we're going to use order of operations. So I'm going to multiply first, so negative 8 plus 4, and then f of negative 4 will equal negative 8 plus 4 is negative 4. So my answer is negative 4. This is the answer. This is not negative 4 times f where you would divide both sides by negative 4. That's the answer. F of negative 4 is negative 4. So I'm going to substitute negative 3 in for x. 3 times negative 3 plus 3. I'm going to multiply first because that's what order of operations tells me to do. Then I'm going to add. Negative 9 plus 3 is negative 6. So my answer is negative 6. I'm going to substitute negative 1 in for x. Negative 1 squared minus 6 times negative 1 minus 3. I'm going to do my exponent first. So negative 1 times negative 1 squared is positive 1 minus 6 times negative 1 minus 3. Next I'm going to multiply. Negative 1 times 1 is negative 1. Negative 6 times negative 1 is positive 6 minus 3. And then I'm going to add and subtract from left to right. Negative 1 plus 6 is 5. And 5 minus 3 is 2. So f of negative 1 is positive 2. Then for the last one, f of negative 3, negative 1 times negative 3 plus 5, the absolute value of negative 3 plus 5 plus 1. So I'm going to evaluate inside the absolute value first. So negative 1 times 2. The absolute value of 2 is 2. So that negative on the outside is negative 1 times 2, because the absolute value of 2 is 2, plus 1. Negative 1 times 2 is negative 2. And negative 2 plus 1 is negative 1. That's the answer to number 20. Okay, so for number 21, we're going to name the slope and the y-intercept, and then we're going to sketch the graph. I am going to put both of these in slope-intercept form. Y equals mx plus b. They're both in standard form right now, so I'm going to move the x to the left. Make sure you show your work if it's not in slope-intercept form. I'm going to have negative 7x minus 16. I'm going to divide by 4. Divide everything by 4. So y will equal negative 7/4 x minus 4. So my slope here is negative 7/4, and my y-intercept is negative 4. To draw the graph, I'm going to go down 4 to the y-intercept. Then I'm going to rise 7, 1, 2, 3, 4, 5, 6, 7, run 4 to the left, 1, 2, 3, 4. I'm going to go down 7, down 1, 2, 3, 4, 5, 6, 7, and 4 to the right, 1, 2, 3, 4. And you could use graph paper if you want to, and then connect the dots. Do the same thing for number 22. Subtract 4x. 5y will equal negative 4x minus 5. Divide each term by 5. So y will equal negative 4/5 x minus 1. So my slope is negative 4 over 5, and my y-intercept is negative 1. Remember, slope is rise over run. I should have mentioned that a minute ago. Graph your y-intercept first. I'm going to go down 1 to the y-intercept, go to the origin, go down 1. Negative 1 is my y-intercept. I'm going to rise 4, rise 1, 2, 3, 4, and run 5 to the left. 1, 2, 3, 4, 5. and where I'm going to go down 4, 1, 2, 3, 4, run 5 to the right, 1, 2, 3, 4, 5. And then I'm going to draw a line through those points. For 22.5, is that written in y equals mx plus b form already? Yes. I don't have the letter x, so that means the slope is 0. And so the 3 is my y-intercept. I'm going to draw that line. The y-intercept is 3. 1, 2, 3. The slope is 0, which means it's a horizontal line. So if you have a slope of 0, remember that's a horizontal line. Next, can you write that equation in the form y equals mx plus b? The answer is no. So this one will not have a y-intercept. And a line that doesn't have a y-intercept is a line that has undefined slope. So the slope is undefined and the y-intercept none. And then to graph that, x equals -1. So a line that has an undefined slope and has no y-intercept is a vertical line. So x equals -1. And that's it. That's that question. Moving right along. Find the slope and the y-intercept of each line. No work necessary for the graphs. Okay, so I'm going to count rise over run. I'm going to start the lowest point, and we'll start here. I'm going to count up 1, 2, 3, 4, 5, 6. So I rise 6 to get on the same horizontal line as that other dot. And then I'm going to run to the left, so this slope is negative. Run left, 1, 2, 3. So -6 over 3 is -2. Now I could have gone up 2, left 1, up 2, left 1, up 2, left 1, and I could have seen that the slope was that to start with, but that's okay. The slope for this one, number 24, rise over run. So I'm going to start my lowest point. I'm going to rise 1 and run 2 to the left. So that makes it a negative slope. So -1/2. And you do not need to make that 0.5. The next one, same instructions. I'm going to rise 1, 2, 3, 4. So rise 4, run to the right, so it's positive 1, 2, 3. So positive 4/3, rise over run. The next one, the only work I can do is write that problem down and write y equals mx plus b. Because it's in that form, the slope is 2, the y-intercept is 5. 27, same thing, y equals mx plus b. The slope is -9 over 2, and the y-intercept is -5. And then the last one is not in slope-intercept form, so I'll show the work putting it in slope-intercept form. Y equals -3x plus 3. And then I will name the slope. That is -3, and the y-intercept is +3. Now we're going to find the slope from the given table. I'm going to use the formula y2 minus y1 divided by x2 minus x1. You can also use constant rate of change if you want, as long as you show that work. So I'm going to use the ordered pairs 4, 8, and 5, 12. Remember, x1, y1, x2, y2. So y2 minus y1, so 12 minus 8. x2 minus x1, 5 minus 4. 12 minus 8 is 4, 5 minus 4 is 1, and the slope is 4 for number 29. For number 30, I'm going to use the same thing, x1, y1, x2, y2, and I'll just use the first ordered pair, -2, -18, and the second ordered pair, 0, -30. So slope equals y2 minus y1 divided by x2 minus x1. So -30 plus 18 is -12. 0 plus 2 is 2. So my slope is -6. And that is all the problems for this assignment. If you need any help, please be sure to reach out. Have a wonderful day.